your distance learning lessons. Today we're going to be looking at refraction. Let's get started with your knowledge retrieval. Pause this screen now and take 2 minutes to attempt the following 4 questions. Okay, you've hopefully paused and attempted those 4 questions now. Get your green pens out and let's go through the answers. Make sure that you can self-correct or change any of your answers in your green pens to match the following. Question 1 asks, what is the electromagnetic spectrum? We learned this a few weeks ago now, but the electromagnetic spectrum is a range of all EM waves or radiation that are arranged according to wavelength and frequency. Question number 2 asks, what does the law of reflection state? The law of reflection states that the angle of incidence is equal to the angle of reflection. Question number 3 is asking you what the normal line is. In physics, the normal line is a line that is drawn at right angles. In other words, it's perpendicular to the boundary that a light wave is reflecting or refracting off of. And finally, question number 4 asks you the difference between diffuse and specular reflection. Specular reflection occurs on a smooth surface, for example, something like a mirror or a shiny piece of glass, and light rays are always reflected in a single direction from that. On the other hand, diffuse reflection occurs on rough surfaces, so this might be something like a tabletop or a window ledge. In this instance, the reflected light rays are scattered in all directions.
Last week, we were looking at the reflection of light. We saw that if we had a light source that emitted light and it hit something like a mirror, we would expect to see a reflected wave. This week, we're going to take that one step further and look at what happened if our mirror was no longer a plain surface, but a block of something like glass or perspex that the light could travel through. So, we have our light source. It will emit a wave in a straight line until it hits the boundary surface of our block. Now, like I said, last week we were looking at our mirror, which was our plane surface. With our mirror, we would expect to see reflected light wave. This time, we're now looking at either a transparent, which means completely see-through, or translucent, which lets some light through, block. In this instance, I'm going to pretend that this is a glass block. Again, our light source will emit a wave. It will travel and strike the boundary of our glass block. Now you will know that if you've got something made out of glass, it still reflects light, so we'll still have a reflected wave. You also will know that if we've got glass, the light is also going to pass through that. When light passes through it, we call that the transmission of light. So the fact that that light wave continues through there is transmitted light. Now, I've drawn 2 lines here to show you that light is transmitted or passed through that glass block. But those directions of light waves aren't entirely correct. You see, what we have to think about is how dense that this medium is. Now, I've used a word there, the medium. Medium is basically just another word for substance. So when it strikes the boundary of a medium, we need to think about the properties of that medium itself. Now, glass is actually much more dense than the air that light wave was originally travelling through. That means that when it strikes that glass boundary, it's not just going to pass straight through like so, because the light wave is actually going to slow down. If it slows down, then that means that the light wave is going to change direction. So we might see something that is a little bit more like this. Our light wave has entered that glass medium, it's slowed down, and therefore it's changed direction. When it comes out the other side of the glass block, once again, it's meeting a new medium, this time air again. Air, being much less dense than glass, means that that light wave is going to speed up. So we get another change of direction. And our light wave is actually going to travel something like this. That change in direction is known as refraction. So we can define a new word, that is that refraction is the change in direction of a wave as it passes from one medium into another. That is a really important definition, and one that you should end up knowing off by heart, because a lot of the time in your GCSE exams they will ask you for a definition of refraction. Now normally if we were at school we would do a practical to show you that this is indeed the case, because right now all I've done is drawn you a couple of pictures that show that that is the theory. Now we're not at school unfortunately, which means that I'm going to have to show you a very, very kind of primitive version of refraction. You can see this a lot of times with some really good examples, and I will show you those. So let's have a look and see how we could do our refraction experiment at home. Okay, so here we've got our setup for our refraction experiment. If we were at school, what we'd be using is something called a ray box. A ray box is a black box with a light source in it that has a cover with a small slit in. Because we're at home, I don't have access to a ray box, so I'm using a makeshift one instead. I've got a toilet roll tube with a torch inside of it, and I'm using an old card that I've cut a slit into. That means that when I shine my torch through the toilet roll tube, you can see our light ray passing out this side. What we'll have to do if we were at school is we would be given a glass block or a perspex block that we would then place in our light ray, and we would be able to measure our incident and refracted angles to show you that we have a change in direction of light as it passes from one medium to another. Again, because I'm at home, I don't have a solid glass block or a solid perspex block. What I've got instead is a glass bottle that's quite thick, but it's got some liquid inside. So that's what I'm going to be using. It should yield the same results. So if I place my glass block onto my light source, and I'm going to draw around the glass block just like we would ask you to do at school. So I'll draw that side, and I'm going to draw that side. And I'm not going to do all around it because it's actually unnecessary. I'm also going to draw or indicate on my drawing the light that is incident on the glass bottle, which you can see down here. So I'm going to draw my ray being shone into the bottle. And I'm just going to draw down that side again because I can see it hasn't actually marked on very clearly. There we go. And I'm also going to draw my transmitted ray. Now that's actually a little bit more difficult for you guys at home to see because it's actually quite bright in this room that I'm filming in. I've got a window to my left hand side, so you'll just have to trust me, and you'll hopefully be able to see a little bit that my transmitted ray is kind of round about there. Now I do also have a little bit of a ray being shone this way, but because that's on the same side as my incident block, that's actually not what we're looking for in our experiment. That's just another reflected ray, but we do that more later. So we're now going to take away that glass block, and what you'll hopefully be able to see is that now that I've taken away that glass block, the path that the light should have followed if there was nothing there passes straight down here. So you can see immediately that without that glass block there, we do have some kind of change in direction. That has meant that our glass block has provided us with a refraction. Okay, just going to get rid of the ray box so that we can actually start measuring these angles, because that's the important stuff. This is what you're going to have to do in your GCSEs. This is the way that these questions are going to be laid out. So, just so we can remind ourselves, that's our glass block. This is our incident ray. And this is our transmitted ray. Okay, and that's the important stuff there. Now, just like in our reflection practical, we want to draw a normal line, because that's where we need to measure all of our angles from. Remember, the normal line is a line that is drawn at 90 degrees to the boundary of the glass block, or whatever medium that you are so happen to be measuring. So take my ruler and I draw on a normal line. That's there. And that's what I'm going to use to measure my incident and refracted ray from. Now, what I'm going to have to do next is I'm going to also have to join up the incident ray and the transmitted ray so I can see what path my light followed inside the block. So I just take my ruler again and I join those two lines together. Okay, so that's the pathway that our light followed through our glass block. And now we can use our protractor to measure our incident angle and our refracted angle. Now, we want to make sure that we're always measuring from the normal line to our ray. So our incident angle is going to be this angle. This is our normal, remember? So it's the angle from our normal to our incident ray, and that is our incident. And then we also have our normal line on this side and our transmitted ray here. That's going to be our refracted angle. Then I'm going to take my protractor and I'm going to measure those angles. So, angle of incidence is roughly about 40 degrees, and our angle of refraction is 30 degrees. So you can see there that once our light ray passes through the glass block, which is more dense, then we end up with an angle of refraction that is smaller than our angle of incidence. So going from a less dense to more dense, the angle of incidence is greater than the angle of refraction. You can see that if we were going to have a look at our transmitted ray, okay, so the one that comes out of the other side of our glass block, and if we draw our normal line here as well, and we're not going to measure these ones, but there's our incident ray and there's our refracted ray. If we go from a more dense medium to a less dense medium, the angle of incidence is smaller than the angle of refraction. So just write that rule down there as well. More dense to a less dense, angle of incidence is smaller than the angle of refraction. And those are the rules that are important for you to follow in this instance. So this is what you'll typically see in your GCSE exams. You might get given a diagram here that doesn't have all of the angles on it, and you'll have to use a protractor to measure, or you might have to tick a box to estimate what angle you have for a refraction given the angle of incidence. And you'll have to be able to recall these two rules. So these are what are important, and this is what you're going to use this week to complete your work.